All right, so let's take a look here at a question that you could see on your test, perhaps a test somewhere in your future, and just kind of how to handle it. So what we've been given is the cotangent of u, and that u is equal to 4x minus 6. So how does all of that work out? Well, what we want to do is we want to find dy dx. And in order to do that, we want to be able to find what du dx is, and we want to find dy dx. Okay, so it's a two-part deal. This is chain rule, is what we're working with. And in order to do chain rule, I'm going to take the derivative of this guy right here. Now you'll notice inside there is a u, and we want dy dx. That's no problem. Here's how chain rule works. We're going to make this substitution here, so we're going to have y equals some u thing. So we're going to find the derivative of y, dy dx, and it's going to be the same thing over here as du dx times dx du, dy du. Yikes. And what ends up happening is the u's cancel, and I'm left with dy dx. So dy du, that's this part that I've got boxed in over here. So the derivative of the cotangent is negative cosecant times u, and then times du dx. Now, I don't know what du dx is. What could that thing be? Well, right over here, I've got u equals 4x minus 6. So du dx, the derivative of this part then, is just 4. Okay? So I'm going to just simply substitute in what I know. I know that u is 4x minus 6. I know that du dx is 4. And I'm going to get my answer. So check it out. My final stop on this journey is dy dx equals negative cosecant of u, 4x minus 6, times du dx, which is 4. Now, as mathematicians, we don't like to generally leave things kind of this way. It's a little messy and not real pretty, or maybe 100% honest looking, you know, shady perhaps. So what we would say is we would just say that we'd move that negative 4 to the front, and we have negative 4 cosecant of 4x minus 6, and that's what dy dx would equal. And this is a very basic problem that uses the chain rule.